Yeah, thank you very much for coming. As Richard said, it's very nice to be back sort of on what feels like home turf, and especially the choice group, which was a regular hangout on Wednesday evenings for me when I was a master's student. So my topic today is going to be statistical biases in peer review. I thought it would be useful to start with the second part of the title, talk a little bit about peer review. Shouldn't really be necessary, I think, but just to remind you that peer review is important and something you should care about. So of course we use peer review in various ways, but most prominently to review journal articles for publication, to review grant proposals for funding, and also conference abstracts often get peer reviewed, right? So we use it in various places, and journal articles are going to be my main focus, and grant proposals I'll mention here and there. We often treat peer review as a kind of quality assurance, right? So the idea is that having been peer reviewed provides you some sort of guarantee that something has a certain type of quality. I'll have a lot to say about that as we go on. Especially outsiders, right? Journalists might ask, is this been peer reviewed as a kind of way to establish that it has certain credentials? But also scientists themselves, especially what kind of journal something ends up in can be an important indicator for scientists about how interested they should be in that thing. So peer review is very important. It controls exposure, right? What works, especially when something gets in a prominent journal, it's going to get likely a lot of exposure that it wouldn't otherwise get. And even, you might say, scientific knowledge is controlled by peer review, right? Because having been published in a peer-reviewed journal kind of is at least a necessary condition, I think, for having some sort of status as scientific knowledge. So, peer review, very central. Hopefully we can all agree at least on this first slide. I'm sure it'll go down rapidly as we go along. But this should be, I think, something we can all agree on. So given its central importance, one thing that we should be quite worried about, I think, and many people are quite worried about, is the phenomenon of biases in peer review. So I put down a little laundry list that I took from Carol Lee's excellent review paper on biases in peer review. Incomplete, I should say. This is not all the biases they discuss. Which you can sort of roughly group in three categories, I think. So here at the top, we have biases that are sort of based on characteristics of the author of a particular article or proposal. So the idea is that that peer reviewer or an editor can be biased against someone based on their gender, race, age, or the prestige of the institution that they work at. Now, for the second, the following two, these are kind of based on the content of the work. So you can be biased based on the methodology that the work uses. Maybe you think that they don't use a method that you think is superior, and that's why you think less of the work. Publication bias is kind of a technical term now. It's used for the bias that says that something has to be statistically significant to be publishable. So it's a bias against statistically insignificant findings, I guess. And then the third category that I wanted to mention is kind of interesting. So Lee notes that there's a lot of inter-reviewer disagreement, right? There's a lot of empirical findings that reviewers tend to disagree about whether something is publishable. And arguably, you could call this a bias if you think that there's a right peer review judgment, because then inter-reviewer disagreement signals that at least one of them is wrong. And so if there's a lot of disagreement, that would be some sort of bias against getting the correct answer out of peer review. So I wanted to flag that as arguably can be classified with these biases, especially if you hold the view of biases that I'm about to show you on the next slide. Right? So we might want to have some sort of definition of what it means for something to be a bias in peer review. And one way to go about this is to come from this idea that bias is supposed to be a quality assurance. So we might say submissions have a certain quality, and that's what we're trying to measure in peer review. We're trying to rank submissions, and we're going to publish those that are highest in this ranking, or in case of grant proposals, fund those that are highest in this ranking. And then a bias in peer review is just any systematic deviation from this ideal. So whenever you're systematically failing to measure the true quality, then you're being biased. So one quote that exemplifies this, in this paper, they define bias as any systematic effect on ratings unrelated to the true quality of the object being rated. So there's kind of a fairly strong notion of quality being posited here, as sort of like a numerical thing that attaches to any given paper or grant proposal. I'm not saying we should agree with this. In fact, I'm going to be quite critical of this definition. But I'm going to explore its consequences throughout large parts of this talk. So this is at least one way you might think of the notion of bias in peer review as deviation from correctly measuring the quality of something. Okay. So now suppose that we think of an editor at a journal or a program director at a funding agency as someone who tries to select for quality, right? They try to get this ranking based on their peer review reports, and when they have the ranking, they select those things that are highest on this ranking. And let's suppose further that they are not influenced by any biases in the sense that I just gave you. Right, so then, so if there's no systematic deviations, right, then they're free from bias in the sense just defined. And what I want to argue in this talk is that there can still be something that I would intuitively call biases in the peer review process, even under these conditions. Right? So even if the ideal that I just gave you is satisfied, there are still going to be these what I call strictly statistical biases. Okay? That arise from underlying probabilistic features of the process that I'm going to go into much more detail to show to you, but not from individual level biases from the editorial reviewers. Okay? And so in order to make my case that such biases exist, I'm going to show you and try to argue that there are I'm going to show you three examples and argue that they are of this nature. So the first is what I'm going to call connection bias. So the idea here is I'm going to show you a model later where the editor is thought of as a kind of Bayesian agent trying to maximize the quality of the things he publishes. And even though she's not biased in the sense that I defined earlier, she's going to end up favoring scientists she knows over those that she doesn't know. So it's the bias of having a connection with a particular author. Selection bias is going to be a slightly different model in which the editor acts more like a frequentist statistician. And I'm going to argue that in that model, the editor, while being unbiased in the strict sense that I defined, is going to have this favoring of certain groups or research programs, and that's going to, I argue, be a kind of bias as well. And then at the end, I'm going to discuss commensuration bias, which is going to be a result of problems that arise when you try to aggregate a multidimensional notion of quality, or when you try to aggregate the reviews from multiple reviewers. So, let me get started. The idea, again, is to show you in each case that something weird is going to go on, and the combined result of this should be that we have this new type of bias, strictly statistical biases. All right, so we'll start with connection bias. And as I said, it's going to be a bit of a formal model to show you how the phenomenon works. So we start from this notion that there is a real quality of a particular paper, a particular submission. And I'm going to denote that as Q. Right, so the idea is we have a bunch of scientists. They're submitting their papers to a particular journal. And they each have a quality, Q, for a particular paper. And it's latent in the sense that the editor has to sort of faces uncertainty about the real value of Q. She doesn't exactly know what it is. I'm going to assume that knowing the author of the paper, right, knowing who wrote a paper, can at least sometimes be relevant when you try to assess its quality. So think about it this way. Each author kind of has their own quality distribution from which any particular paper is going to be drawn, right? And those can, in principle, be different. Some authors always write good papers, some authors always write bad papers, some have high variance, some have low variance, whatever, right?
Sorry, what is Q? What is K?
Okay, right, so that is, can I just take 1 second to go through this and then ask again? So the idea is, so if the editor knows a particular author, right, they might know exactly what their quality distribution looks like for that particular author, right? And so then K, so then the prior that you have for the quality of this particular paper is going to be the quality distribution of that author, right? Because that's what you expect the quality to be. So in that case, K is a variable that gives you the information that this is the distribution for that particular author, right? But more generally, maybe it only gives you partial information about what the distribution looks like. So K is just representing whatever information you have about the quality distribution of this particular author. Right. Whereas if you don't know a particular author, you don't know anything about their particular distribution, you still have to have a prior for this particular paper, and so that's going to be some sort of aggregate distribution which factors out the uncertainty about the particular quality distribution of this author. Does that make sense to everyone? Okay. Now I'm going to further assume that it doesn't, overall, it doesn't actually matter whether you're known or unknown, in the sense that as a group, the authors whose identity is known, whose quality is known to some extent to the editor, they actually have the same quality distribution as a group as the unknown authors do, right? So if you average out over all the scientists in the community that the editor knows, then you actually end up with the same distribution that you're using as the prior for the unknown scientists. Now the editor is going to do their, going to collect their reviewers' reports. One or more reviewers report something back. Whatever they report is collected in this one variable R, and that's going to give you some information about the quality of the paper based on what the reviewers say. I'm going to assume that that's independent of the author identity, so the review report doesn't depend on the identity of the author given the actual quality. So real quality screens off author information in the case of the reviewers. Perhaps double-blind review is used. That would be the obvious way in which you can completely keep author identity, or try to keep it sort of off the table. Or maybe you just think that this is a natural feature of peer review, that once you read a paper, you actually learn something about its quality, and that sort of blocks out any previous expectations you might have had. So once you get this review report, that's obviously also relevant information about the quality of the paper that you get as an editor. And now we're going to get a nice Bayesian update. Remember, as I said at the beginning, this is going to be a Bayesian model. So we just condition on the review report to get a posterior distribution for the quality of the paper. So if you know this author, you now have this distribution, and if you don't know the author, you get this. Pretty straightforward, right? Just Bayesian in conditioning, you get a new probability distribution for quality, which we call the posterior. Now, the editor, based on their posterior distribution, must decide whether to accept the paper or not. And as I've said at the beginning, I want to explore this idea of selecting for quality, so I'm going to assume that that's the only thing the editor cares about. And so that's reflected in her utility function. If she accepts the paper into the journal, then its real quality Q determines her utility, right? So the higher the quality, the higher the utility for the editor. And if you reject the paper, you get a fixed level of utility because you didn't publish the paper in your journal. So think of this as a 0 level, which I denote Q star.
So no regret.
Right, so the editor doesn't care what happens to the paper if she doesn't publish it. Right. And then it follows, if the editor is a rational Bayesian utility maximizer, that she'll accept the paper if and only if the mean of the posterior distribution that she has for the quality is greater than this threshold value Q star. Okay? So, one thing I want to observe about this is that the editor is actually using subtly different decision procedures for the two groups, known and unknown authors, right? So if you describe it at this level, it sounds the same, but here you see actually slightly different expressions are being evaluated, right? The mean of the posterior distribution here is conditional on something extra that doesn't appear here. So in principle, slightly different decision procedures are being used. The editor has more information available to her when she knows a particular author. Now, this is going to be the main result of this section. There's one more assumption which I think is pretty innocent. So I'm just assuming that there's at least a positive probability that knowing the author, at least for some authors, for a positive measure set of the authors, it's the case that knowing that author changes the probability that their paper gets accepted, right? So that it actually matters whether you're in the known or the unknown group, for at least some authors. Okay, if that's true, then at least one of these two inequalities can be shown to hold. And the first equality says that the known authors have a higher acceptance rate. So if you're the authors known to the editor as a group have a higher chance of getting their paper accepted than the unknown authors. And the inequality on the right says if you look only at those papers that get published, right? So given that a paper is accepted, the average quality of those papers that get published that are written by an author that's known to the editor is higher than the average quality of those papers that are published that are written by an unknown author. So, and at least one of these two things holds, right? So there's an or there in the middle. Right, so in order to prove this, you use Good's value of information theorem. For those of you who are familiar with that, I'm not going to go into the details here, but that's what it's based on. Is there a question there?
Yeah, I mean, maybe you will clarify this later. But doesn't this depend on what I know the author for? So if I know the authors to be if conditioning on knowing the author means that I expect it to be of lower quality, so it holds independently of what it means or what I know about the author.
Right. So I wasn't sufficiently clear there. So on the individual level, it can go either way, right? If you know a particular author is really good, then you're more likely to accept their papers than an unknown author. If you know that a particular author is really bad, you're actually less likely to accept their paper than an average unknown author. But the point is, if you look at, on average, all the known authors are of the same quality than all the unknown authors, right? The distributions are the same. But at the group level, if you put all the known authors together, it balances out in their favor. Does that clarify? Yeah. So this is for an arbitrary known author, right? Yeah.
Sorry, it's just clarification. So is the idea, so the first bit is the if, so if this holds, then we'll get either this or this, right? Is that right?
So the then is at the end of this sentence.
Yeah.
Yeah.
So I don't know if I'm reading it right, because it looks like, just reading intuitively, if the first thing holds, then the first disjunct should hold, right? I mean, it just looks like, so does the first disjunct say that the probability that the known author will be accepted is greater than the probability that the unknown author will be accepted? That looks, just reading it, the same as the thing after the if. What's the
let's see. So as I was just saying to Suzanne, right, for an individual author, it could be that the probability of being accepted can be either increased or decreased by the extra information that's available to the editor, right? And so there's at least some authors for which it changes at all, either positively or negatively. That's what the if here is saying.
The if says what?
The if says that there are at least some authors in the population for whom knowing them gives you sufficiently relevant information that it changes your probability of acceptance, either making it higher or lower.
Oh, I see.
Yeah? And then this is saying that at least one of these two things happens, of which the first disjunct is that it favors the known authors, which is left neutral in this if statement here. Yeah?
Just sort of very intuitively, I mean, this doesn't go in the model, but I mean, what happens in the real world, of course, is that if I don't know the author, I look carefully at the paper. Whereas that if I do know the author, I say the author is really good, then I'm just gotten to the emperor's new clothes. That is, I don't look carefully at the paper. And then it may be the case that I'm expecting that, if you take that variable somehow measured, to be very disparate. Yeah, become completely blind once I know the author, right?
It sounds like
it
it goes in the same direction, right? As the effect I'm describing. I'm saying even if you hold them to the same standards otherwise, you give them equally strict peer review,
I see. So that's where
and you hold them to the same standard with this Q star threshold,
I see.
then you get this effect, even without having looked more carefully or less carefully at something.
So open to the same peer review is equivalent to looking with equal attention to the known and the unknown authors.
So I didn't get the first
Well,
one. So what is equivalent?
Being subject to the same peer review. I mean, peer review, that's
Right.
determines the reliability of the process by which you make your assessment. Yeah. And of course, what happens in reality is that the reliability of the process by which I make my assessment will be worse, will be lower than for a known author than for an unknown author.
Right.
That's
So the lower reliability effect that you describe is not in my model.
Yeah.
But what I do have in my model is that the standards are different for known and unknown authors. That just
That's right,
follows
yeah.
from this.
Yeah.
Right. Okay. We good?
So I just wanted to know where the emperor's new clothes were. Yeah.
Right.
And I
So-
think you exclude them by means of having the peer review fixed.
I think I'm excluding the effect you're describing. Yes. Right. Okay. Yes.
Maybe just so I talk a lot to mathematicians, and my understanding is that in mathematics people are extremely worried about the negative reputational effect of ever publishing a paper in which they announce a theorem which then turns out to be false.
Mhm.
And they're worried, I mean, of course they're worried intrinsically, but they're also worried for reputational reasons,
Sure.
because the worry is then that their proofs will no longer be trusted as much by other mathematicians, including peer reviewers in the future. And so the effect would be peer reviewers have only a limited time budget and are able to give not a sort of total scrutiny to every proof. That is just not feasible if you have to review a detailed, elaborate mathematical paper. So you sort of need to cut corners to some extent. And then if the author in question has a reputation for impeccable mathematical correctness, that obviously then will be the sort of information that will increase the reviewer's posterior probability that the paper really does achieve what it says it achieves. Whereas if the author is either unknown or if the author is known to have a track record of publishing flawed theorems, then it can bring down that posterior probability. And it seems to me that
That's
sort of
basically
effect
what I'm
is,
trying to
yeah,
capture.
so it seems to me that effect is actually captured, and that would actually apply that effect even if you hold the time budget and attention span of the reviewer entirely constant.
Yeah. If I understood you correctly, I agree completely, and that's what I'm trying.
Right,
to
exactly.
do.
Yeah,
It
so
is
that's
slightly
meant to be a
different
sort
from
of
what-
it's meant to be a
Yeah.
sort of supportive remark
Right.
for the effect you described.
Good. All right. Okay, so we're on the same page on this. Then I just want to point out, right, that this basically looks like a bias to some extent in favor of the known authors, right? Because either you're going to, if you're the editor, right, either you're kind of facing a dilemma. Either the first thing is true, and then you're just giving more exposure in the journal to the known authors relative to the unknown authors, even though you know, or at least believe, that the incoming quality is the same from both groups. Or you face this other problem that people will see that the average quality of the work that you publish from the known authors is higher than the work that you publish from the unknown authors, which you actually know to be misleading because you know the incoming quality is actually the same. I think you shouldn't like to be doing either of those things as an editor in this case. So that's the sense in which you kind of face a dilemma. And on either side, I think you're kind of you're kind of displaying some sort of bias in favor of the known authors. And it can get worse, right? when you fill in the details here, what do these quality distributions actually look like, which I did in a previous paper using normal distributions in all the relevant places. And at least in that case, what you actually get is that both of these inequalities hold. Right? I think that definitely looks bad. So this is the phenomenon that I'm calling connection bias here, where the editor is trying to select for quality, but the sort of the output that she produces appears to be biased in favor of authors that she knows.
But they might still be selecting for quality, right? I mean,
They are.
They are indeed.
So that's what
because
I'm
you
saying
said they
here.
appear to be selecting for quality. They are selecting for quality.
Right. So what all the editor is doing is making maximum use of the information that she has available to her. Right. So it just happens to be a fact of the world, I've assumed, that the editor knows more relevant information about the quality of papers when she knows the author, and so she can make better decisions. And one of the ways that sort of plays out in the results is that she can basically either accept more papers from the known authors without loss of quality, or she can accept better papers from the known authors because she has more information about them. Right? So she's in a position to make better decisions about those authors. And that's how this plays out, which favors the known authors.
The question is whether you want to call that a bias.
Yeah.
That's not so clear to me, but
Sure.
I mean, because you can use the term in different ways.
Right. Yeah, so I am calling it bias. Right. And so it is true, I think, that the editor treats the authors differently, even though in a different sense she's holding them both to the same and to a different standard, right? She's holding them to the same standard in that the posterior mean quality needs to be higher than Q star. That criteria is used for everyone. But she's using them differently in the sense that as a result of that, she ends up either accepting more papers or accepting better papers from the known authors than the unknown authors. And so I would describe this process as looking biased, even though it doesn't match the definition of bias that I started with. So I think it's explicitly true that under the definition of bias I began with, of just measuring true quality, this would not count as biased. Okay. So you might diagnose this problem as saying, well, the problem that you have here is because you have this prior information that you shouldn't be using, right? Maybe you think it's unfair, or you call it a bias, like I do, or maybe, right, anyway. So you might think we shouldn't be doing that, right? The editor shouldn't insert her own information, her own prior information about the author into the decision-making process. The editor should take a more passive role, only look at the review reports and accept or reject based on those. So she should be more frequentist in that sense. You might think, and that's going to be the topic of the next section. Yeah, I mean, you might also not think this, right? You might also think, as you were kind of suggesting, that, well, it would be a shame to drop this prior information because it's relevant information. So the model I'm going to show you next is one in which, at least from a Bayesian perspective, the editor is going to do it more poorly because she's not going to use prior information. Okay? But it is a way to address this problem if you think it is a problem. So that's what I'm going to do now. So in this section, I'm going to have a slightly different model in a number of ways, but you'll see some similarities as well. So now I'm going to drop the assumption that the underlying quality distributions are all the same. So I'm going to forget about the known and unknown authors. That doesn't play a role anymore in this section. But now we're going to imagine two groups, two research programs that the papers that are being submitted can be divided in. And we're assuming that they actually have different quality distributions. One is just better than the other. I'm going to call the established research program and the novel research program. For purposes of this talk, those are just labels. I don't think it's doing very much work. But the sort of vague thought behind this is you might have an established research program that's sort of relatively reliably putting out good work, and a very young research program that is a bit more all over the place. There are a few cranks mixed up in there, hasn't quite reached its full potential yet, and so the average quality of the work that it produces is a bit lower.
But isn't there an attraction to the editor of the novel program that this might be the one that makes the big splash? I mean, it has a chance of being more original than the other one. The first paper in a new field.
It does, yeah. I think that's a good point, and it's relevant to what I'm about to say. But I think it's better to discuss that when we have the material on the table.
But there's the lower mean
It just
higher
preempts,
variance.
sorry.
The lower mean higher variance effect, that might also be.
Could be, yes. I have sort of formal details on that, but I'm not really going to discuss them here. I'm going to only talk about difference in mean, but we can talk about what happens if you play with both at the same time. That's a footnote somewhere. So what I'm here going to do is only look at the difference in the mean, and I'm going to make a slightly more specific assumption on the distribution that quality follows. So I'm going to make a restriction and look only at log concave distributions. That's a kind of technical restriction. It's non-parametric, but a bunch of distributions satisfy it, right? So these 4 examples. So pick your favorite one out of these, or any other log concave distribution, and we assume that quality follows that particular distribution in each of the research programs, and that the only difference is that in one of them the mean is higher than in the other, right? So the established research program I'm going to call H has a higher mean than the novel research program I'm going to call L. So, so the model, we get a review report again, which, again, similar to before, it's going to be unbiased in the sense that given the real quality, and now this condition here is really important, given the real quality of the paper, the review report doesn't depend on which research program the paper originates from. Given that it's just an unbiased measure of quality, of course, if you remove this condition, of course it will differ, right? So obviously the better papers are more likely to receive a good review report. Right, so papers from the established research program are more likely to receive a good review report because they're more likely to be better. But conditional on the actual quality, it's independent. Okay, editor decision to accept or reject. And now we have this more frequentist editor who doesn't have a prior, but she's still trying to select for quality, and the way she does this is by looking at the reviewer report and accepting the paper if the reviewer report exceeds the threshold value, which for convenience, let's call that Q star again. So in this case, we're going to have identical decision procedures for the 2 research programs, right? Regardless of whether you're in research program H or L, the condition for publication looks exactly the same. And so in that sense, we're avoiding a bias due to the information asymmetry that we saw in the previous section. So in that sense, we're successful. We're avoiding connection bias. However, right, the however comes in the next slide. So, and we're avoiding connection bias, so that's good. And I just want to point out that I'm not going to make a distributional assumption on the review report. So we have made a distributional assumption on the quality. I'm not doing that for the review report. I'm really only assuming that the review report is positively correlated with quality. And the way I express that is that the probability of acceptance, right, the probability that the review report exceeds the threshold, given the real quality, this is a function of the real quality, and that should be an increasing function, right? So the acceptance probability should get higher as the quality goes up. That's really the only role that the review report actually ends up playing in the model is through this function, and this is the only assumption I make. So, now, in order to show you the result, it's going to be convenient to introduce this notion of suitability, which you shouldn't put too much interpretation on. It just means that quality exceeds a particular threshold that I'm leaving unspecified and just calling T. So let's say that the submission is suitable for publication if its quality is greater than T, and unsuitable if it's less than T. Okay? Then I can state the results in terms of the probabilities that are related to acceptance and suitability. So the claim is that peer review is going to work better for the established program H than the novel program L. And this shows up in the probability of suitability given acceptance and the probability of acceptance given suitability. Okay? So a greater proportion of accepted papers is suitable, right? A greater proportion of accepted papers from the established research program is suitable than the proportion of accepted papers from the novel research program that's suitable. And similarly, suitable papers from the established research program are accepted at a higher rate than suitable papers from the novel research program, except for a footnote about possibility of inequality there. So So peer review works better in the sense of, you might say, lower error rates for the established research program, right? So I think I have a figure coming up where you can think of suitability and acceptance in terms of true positives and true negatives and so on. And then false positives and false negatives are errors in that sense, and that's the sense in which you can interpret this in error rates. I'm going to come back to this figure in a second, but just to make the point that this is essentially talking about error rates. So the error rates are lower for the established research program. So this is based on a previous paper by Danny Borsboom, Jan-Willem Romein, and Jelte Wicherts. Jan-Willem is familiar here, I believe. This part of the paper, I forgot to mention that earlier, this part is actually collaborative work with Jan-Willem. So we generalized the previous result from them. They use normal distributions, we use log and cave distributions. And also we applied to peer review. This paper was about psychometrics. And I should mention that Borsboom also talked about the possibility of the mean and the variance both changing at the same time. And there is a condition that you can formulate that involves both the mean and the variance changing at the same time, under which you get a similar result. But I think it doesn't really matter for the philosophical point I want to make, which is that this kind of phenomenon can happen. Okay, so let me give you a little bit of intuition for what's going on here. Right, so if you put quality on the x-axis, right, and so the threshold T is here, so you have suitable and unsuitable papers. And here's the reviewer report with the threshold for acceptance and rejection. Then we can think of these four quadrants in the graph as true positives, false positives, and so on. And so now, if you're thinking conditional on acceptance, for example, then you're looking at the top half of the graph. And so the probability of suitability given acceptance for, oh, this is wrong. Right. So if you're in research program H, right, then the probability of suitability given acceptance is the ratio of this area here to this area, right? And so that, you know, this area is bigger than this area, so let's say this is about 3, so then the probability of acceptance, the probability of suitability given acceptance is, let's say, 3/4, right? But for group L, the ratio of this area here to this area here, well, this one's about 3 times as big as this, so that actually the probability of suitability given acceptance is only, let's say, 1/4, right? So the idea is, even for those papers in group L that get accepted for publication, those papers tend to be relatively close to the threshold of suitability, and so they're relatively more likely to be errors, to be unsuitable, than papers from research program H. So that's roughly how this result works, and if you look towards the ratios on this side, you get the converse result of probability of acceptance given suitability. Right? So the location of these probability distributions, with H being shifted to the right relative to L, makes it such that not only are they just on average better papers, but the error rates of the process that's trying to select for quality are different for the two programs. Okay, so I just want to briefly connect this back to the kind of results we saw in the previous section. So we can draw a corollary of the results that I just showed you, which tells you that for research program H, there's both a higher acceptance rate of its papers and the mean quality of published papers is going to be higher. Right? Remember in the previous section it was an or in the middle, now it's an and. And I think we need this and here to be able to think of this as problematic, right? Because now we've assumed that the research program H actually is better on average. So it's perhaps not surprising that we accept more papers from it, right? That seems reasonable if we're trying to select for quality and the average quality is just higher in program H. But even given that we're allowing more papers in from research program H, it's still the case that the average quality of those we accept is higher, right? So it still looks like we're actually, from the perspective of the reader of the journal, it actually looks like we're using different standards for the different groups. And in fact, the readers might well think that the editor is using positive discrimination in favor of group L, trying to give them a leg up, and thereby letting in, and that's why we see that their average quality actually ends up being lower, right? That would be a reasonable hypothesis for a reader to have, in the situation. So in that sense, readers of the journal are going to think, actually, the editor might be helping them, or for whatever other reason, they're just publishing all these poor papers, so they're actually going to think quite poorly of research program at all in this kind of situation.
If you start thinking about what this means for scientists self-selecting into the different research programs, I mean, you could have something like a market for lemons sort of situation, where basically the L research program completely disappears from the market, right?
Right. So
very quickly, too, if you figure that out.
Yeah. So I think, I hadn't really in my head put it in the terms of self-selection, but the phenomenon you described is exactly what I had in mind. But the result of this is going to be that it's going to be very hard for the novel research program to establish itself. It might get wiped out. And that's the worry here, right? That this novel research program, which is not yet quite up to speed, okay, fine, its average quality is lower, so it's reasonable that it doesn't get accepted quite as much. But if also the average quality of accepted papers is lower, and has these higher error rates, then it looks even poorer than it really is, in a way. And that's why it's going to have a really hard time establishing itself.
Yeah, this could be an incentive mechanism that contributes to the entrenchment of a Kuhnian paradigm. I mean, that's perhaps one of the mechanisms that would explain why paradigms can be so stable. And only when the leading paradigm is really in big trouble, I mean, that would probably be the time where the quality of the established paper starts dropping because the paradigm is in trouble. Then it's easier for the new work in the new paradigm to break through. I mean, that's sort of the Kuhn idea.
Yeah, so
I said what you responded.
That's exactly right. So the in this, because here I'm focusing on this phenomenon of statistical biases. So here, established versus novel research program doesn't have a very solid interpretation behind it. They're just labels. But in the paper I'm writing with Jan Willem, this is exactly the point we're trying to make. Like, this could be a mechanism that helps entrench existing research programs at the expense of novel ones. Yeah.
I mean, casual observation, at least from where I view things, would be that very often new journals from the new novel research programs start up exactly for that reason.
Oh, interesting. Yeah. Right. That's obviously something we're not incorporating here. We're just working with one journal. Good. All right. So I've just basically said this, right? The idea is that this is, again, this type of what I call purely statistical bias, because, at least to me, it looks like we have a bias against research program L in this system. But again, according to the definition of bias that I started with, this would not count as a bias, because we're purely selecting for quality in that unbiased sense. There's no systematic deviation from our measure of quality at the paper level, right? That's the important point. For any given paper, we're just giving an unbiased measure of its quality and deciding publication based on that. So in that sense, it's unbiased. But at the group level, research program H is doing much better than research program L. Okay.
Can I just say about the quality question? Do you use quality as the benchmark for bias that provides you with a kind of clean way of thinking about what things which are biased might be? I suppose the reason I'm asking is, you might think that there are non-quality related reasons, which nevertheless could be good reasons to have. And I actually don't mean this in terms of like social transformation or anything. I mean like Philip Kitch's prudential argument that you should fund research programs you think are wrong rather than putting all your eggs in one basket. And his argument is just that kind of, for probabilistic reasons will be a sure thing in the long run. And that would be an argument on epistemic terms only, if you like. That means to do something that isn't quality seeking.
Right. So I think on one level you can interpret what I'm doing here as further support for trying to do something like that. So that's sort of immediately addressing your question. But also I have a bit more to say about quality, and that's actually what's coming up right now. So you might say the problem is with this. The problem that you're seeing in these two models is that you've put this quality ideal so central, and maybe we just shouldn't be thinking in terms of, well, maybe this notion of quality is more complicated, is what we're going to do next, and then maybe towards the end we might even say, we might want to even get rid of it altogether. But for now, let's just at least point out that quality can be a bit more complicated than this unidimensional, strict, this total ordering that I've assumed so far. And let's at least, let me skip this for a moment. So let's at least point out that we might want to have a multidimensional notion of quality, right? We might at least want to have multiple criteria that we take into account that determine whether we consider a particular paper to be publishable. And moreover, of course, I've so far assumed that the review report just comes neatly packaged into one number R that we can use as our measure of the quality of the paper coming from the reviewers. But also there you have, quite often, of course, 2 or 3 reviewers that are providing their reports, and those need to be aggregated, right? So we're going to talk a little bit about social choice theory here, about how to aggregate multidimensional notion of quality into sort of an overall ranking of papers, and how to aggregate the rankings of multiple reviewers into sort of a final ranking that the editor uses to make her decisions. And Carol Lee has talked in a different paper than the one I quoted before, has introduced this notion of commensuration bias, where she points out that it's at least possible that we could be biased in our method of aggregating these different things. Right? Our method of aggregating these things could be sort of biased in the sense that it's systematic, that the method of aggregation, the way we go from the criteria rankings to the overall ranking, could be a step in which bias creeps into the process.
There is a little step in between that, because it's not obvious that you have to aggregate. I mean, there would be dominance criteria that enable you to choose on the boundary where the trade-off is, without necessarily aggregating these.
Right,
I mean, you want to...
aren't you still? I mean, in some form or other, you're making a decision because you're publishing one paper and rejecting another. So I feel like there's kind of an implicit aggregation there that says this paper is higher than the other one.
Well, but suppose you chose, you have a boundary between the different criteria 1 and 1 axis, criteria here, and you have a boundary of the feasible set of papers. And let's suppose you just sort of counted up the ones on the boundary, and you got enough pages in your journal to fill that.
Right.
Then you wouldn't have aggregated in any obvious way. You just used a dominance criteria. So, but it's fine if you want to assume just address cases in which there is aggregation.
Right. Yeah. So I guess I'm assuming that you've done slightly more. I think I have this on a slide that comes up. But basically, my thought is, you might not know your page limit in advance. So basically, you need to have a complete ranking of the papers so that you know which ones to publish given the page limits that you have. Yeah, I'm going to assume that we need a full ranking. And the other thing I wanted to point out, I'm not going to go into detail here, but I do actually think that this is not a particularly promising way out of the problems I sketched previously. Right? My thought here is, and I haven't spelled this out in detail, so I'm happy to take feedback on this. It's sort of a relatively vague idea. But my thought is, look, you're still making acceptance-rejection decisions based on these various criteria and review reports. And so it seems to me that implicitly there's some sort of overall ranking still going on. And so there's some metric on which you have now ranked these things, even if it's an implicit one. And whatever that metric is, I could call that quality if I wanted to, and then under that metric, you're going to be sensitive to the biases I described before. That's my worry. That suggests that even if you accept this and think it's going to be a better way of looking at the problem, it's not clear you're going to be able to avoid these problems that way. But now I want to sketch some ways in which additional problems come along. So this is newer work, more work in progress. See this part. I'm just going to sketch a very basic model to suggest why there might be good reason to think that this might introduce additional biases. So let's first think about aggregating from multiple dimensions of quality to sort of an overall ranking. Right, so the editor asks a reviewer to give a ranking on some criteria, and to also provide with that their overall ranking of some set of submissions that they're asked to review. And we're assuming that the criteria ranking is, on each criteria, the reviewer is able to form a complete reflexive and transitive order of preference of which paper she thinks scores better on those criteria. And the editor wants from the reviewer a similarly complete reflexive and transitive ranking of the overall ranking.
Why would you want that? Because if all that matters is a choice, I mean, it's quite special to ask for a complete, complex, and intransitive ranking. I mean, why not, for example, one that's only quasi-transitive, or even acyclic, or perhaps just aggregating these things into a choice function?
Right. No, I think that's completely fair. That's part of why I'm saying this is a bit more preliminary work. I just want to sketch out a problem here that could happen, and part of why I'm not going with a choice function is again this idea that like you might need a bit more information than just a choice if you don't know your page limits in advance, for example. So you might want to have a sense if you're rejecting papers for which one was the next closest one, for example, so that if it turns out you have more space, you could do an extra one. But I think here also, I think this is perhaps more appropriate here to think of grant proposals for that point. So you might, I think this is actually a bit more common even than with journals, that you don't know your funding limit in advance. So we're trying to rank all these grant submissions, figure out how good they are, and then it might well turn out that we don't have enough money to fund everything we thought was acceptable, and so we better have had a sort of more fine-grained ranking of them so that we now know, given how much money we actually have, which things we can fund. So that's why I want a little bit more of a ranking than just the choice function. Yeah.
It also assumes some kind of independence, though, in the sense that for a journal may like to have two related papers for some reason, giving somewhat different perspectives.
Right. Good. Yeah.
So you assume some kind of independence that rules that out.
So I think it can be, so put it this way, the kind of ideal that I'm ultimately criticizing here, I think does seem to implicitly assume that kind of independence, right? The idea that there's this true quality out there that we're trying to measure seems to suggest that those kinds of considerations don't come in. On the other hand, if you think they should be in there, you might just be able to have that as a criteria. Let's see, would that work? I guess it's not completely straightforward. Yeah, but
you'd want to bundle this
you could just have that bundles,
into some combined.
Right, so you want to compare bundles instead of individual submissions. Mm-hmm. Yeah, so I don't have an immediate answer for what that would mean in formalism.
Research councils ask us to do that.
To do this, right. Yeah, I mean, everyone we've talked to who's actually been involved in grant proposals has said, like, this is roughly what they're asking for, right? So, yeah. Again, I mean, especially in this part of the talk, the model here is very simple. It's just meant to be suggestive, right? I mean, I'm not going to do anything new formally here. Just pointing out that these kinds of problems that we already know from social choice theory are potentially relevant in this context. So we would want, to have a way of aggregating these criteria that's somehow bias-free, right? That doesn't favor particular submissions and it also doesn't favor particular criteria, right? Because if we're doing this multidimensional notion of quality, it should really be a multidimensional thing where each of the criteria plays a role. So that's the challenge. And then we have our usual desiderata. This is all very familiar. We would want to allow any ranking of the criteria and still be able to say which things we're going to publish. We want it to be the case that if one submission is better than another on all criteria, then it's going to be higher in the overall ranking. Otherwise, it seems like you have a bias against a particular paper in advance, right? You wouldn't want one criteria to dominate the overall ranking, right? Because then you haven't really moved to a multidimensional notion of quality. And arguably, you might want something like independence of relevant alternatives, because you might want, again, you might have this underlying idea where quality of these criteria is supposed to be a feature of these papers. It doesn't depend on what else is available. And so if you have the relative rankings of two submissions, that should determine the relative ranking to each other in the overall ranking. If you were violating this, you might call this a kind of menu bias or something. So the thought is, right, we know, of course, by Arrow's theorem, I'm assuming this, in this group, I'm assuming I'm not telling anyone anything new here. We have a theorem, very old theorem already, that tells us that we can't have all four of these desiderata at once, assuming there are at least 3 submissions. And so the thought is, if you think that each of these 4 desiderata is a criteria that you have to satisfy in order to have an unbiased aggregation method, then it follows that you're going to have a biased aggregation method, right? And so that it's impossible to avoid commensuration bias. Now again, we can of course pick at the assumptions, and I'm sympathetic to that, and I'm happy to hear, but just to finish my sentence, right? I'm not saying that I don't want to actually really, I don't think I really want to defend the claim that it's impossible to avoid commensuration bias, at least not just on the basis of this simple model. But the point is, just to remind you, social choice theory is hard. Aggregating things is hard, and it seems to me it's going to be very easy to fall into commensuration bias. Yeah, go ahead.
So it's just that one other assumption that's a little bit hidden is that when one talks about complete reflexive and transitive rankings, there has to be a set, a predetermined set to be ranked by those rankings. So, and it's not obvious to me how that fits here, because next year there'll be a whole new different set of papers.
Right.
So you need to fix the universal set over which those binary relations are defined.
Right. So we have to think of a very relatively short amount of time in which a reviewer is reviewing papers, or a single session of a grant funding body's meeting in which they have a particular set of submissions that they need to decide which to fund.
And that repeats itself next year.
Right, exactly.
There could be inconsistencies.
Right. But again, if you follow this ideal and you think, we're just trying to judge these things on their merits, which are supposed to be somewhat independent of what else is available, then it shouldn't really matter that much, except insofar as maybe the poor papers would be good enough in the next round, but then hopefully they're just resubmitted, so I don't know. Yeah, so Eric.
Yes, so previously I thought that Q was, so the quality was a real value quantity, so when we move to the multi-dimensional setting, couldn't we potentially get around some of these issues if we let it be real valued rather than just a ranking?
Right. So if you, as long the informational basis issue from error, right? So as long as you have either ordinal or cardinal rankings and no intercomparability of the different criteria in a straightforward way, then you still get this problem. If they're real numbers in the sense that you have a 0, right? So it's a ratio scale. Then you have some kind of implicit comparability, and so then you have a way around this, yes.
Is the assumption of independence reasonable in this case? Do you think perhaps that if you're editing a journal, you might have criteria that apply to groups of things that you're choosing together? Like you don't want to publish all formal epistemology articles because you're not a formal epistemology journal, you have BJPS, and so you would exclude certain choices on the basis that you've already chosen other things, which would break, I believe, that one. So you just might not want it, in which case it doesn't arise.
Yeah, no, I do think, so 2 things. I do think independence is clearly the weak point if you look at these 4 desiderata in terms of, the first 3 I think is pretty straightforward, pretty easy to argue that they represent sort of bias if you violate it. Independence is a little bit less clear. The defense I would give is that in the story I'm trying to tell, so if I'm committing myself to this idea of unbiasedness being cashed out in terms of these criteria rankings that are sort of fairly, I skipped that quote I think from the Lee paper. So this is their understanding of bias when you have multidimensional quality that's still sort of along the lines of the quote I gave in the beginning. Right, so impartial reviewers arrive at identical evaluations of the submission in relation to evaluative criteria because they see the relationship with the criteria to the submission in the same ways. So I think the idea is supposed to be, in this kind of quote, and also in the quote I gave in the beginning, I interpret these people as talking about the way these things are supposed to be evaluated as independent of other submissions. But I think that's a fair interpretation of what these people who defend this are trying to do. And so in terms of giving imminent critique, I think independence is somewhat justified. But even if it's not justified, right, it's still the question, well, if you're not going to even if it's, even if you're not running into strict impossibility, there's still the question of, well, how are you going to aggregate these things, and is that thing really, can you really, so if you drop independence, right, you might end up with some scoring rules, for example, and then, well, are you going to use the border count or something else, and which one of those is unbiased, and why, right? These are, I think, ultimately the questions we would need to be asking here, to see whether we could really say we're free from commensuration bias. I don't think it suffices to just say we think independence doesn't need to be satisfied. That doesn't end the story.
One version of the border count, the narrow, so-called narrow one, doesn't give you complete reflexive intransitive ranking, so you need to be sure that you assume the so-called wide border counting. So the particular scores don't depend on the number of things available.
Right. Sorry, and why are you saying it's that important?
Well, because you say you gave reasons for wanting an aggregate weak order, and not all of the scoring rules do that. There are narrow versions which don't do that. They just give you a choice function.
Is that right? Well, I'll take your word for it. Then yes, then you need to be careful with that. Right. So,
just one comment. I mean, I guess the sort of border count that would unproblematically yield a ranking is simply one where you've got, let's say you've got k options that you want to rank, and then the border scores are simply based on how many of these k options each option beats. Exactly. So then the border scores can go from k-1 to 0 or from k to 1, depending on how you count, and that sort of border rule will always give you
that version will be fine.
Yeah, that I guess is the sort of that is sort of the super classic border count.
Well,
yeah,
there are the narrow ones.
Yeah, that's right.
They
Yeah,
don't.
Yeah.
I mean, that one doesn't satisfy IIA. And the narrow one does, but fails to satisfy alpha of the contraction.
Right, but the narrow ones would be defined for aggregation rules that deliver choice functions as opposed to overall orderings. Right.
yeah. Shall we move on? It seems like a bit of a side point. So, right. Yeah, obligatory citation of Akasha, because of course this is very much along the same lines of applying arrow to a situation where you have different criteria, in this case for theory choice, in my case for peer review. And then just to make the same point again for multiple reviewers, right? So if you somehow solve this, now you have the rankings from a number of reviewers, 2, 3, or whatever, and you want to aggregate those into your final ranking that the editor is actually going to use to decide what to publish. And so you might again have a bunch of desiderata for doing that, and you're going to have still Arrow's theorem. So we can kind of see how there's 2 points of aggregation here potentially at which bias can creep in. Is the point I want to make here. And so what I take this to show, if not that, like again, I don't want to say super strongly that like, oh, it's impossible to do commensuration. But what I want to point out is I think it's not obvious that it gets around connection and selection bias, as I said at the beginning. And so moving away from unidimensional quality to multidimensional quality and pointing out that there are multiple reviewers, I just think it doesn't solve the problem I started with, and it might introduce more problems. Maybe it doesn't, maybe there are ways around this, but then at least you haven't really made your problem easier by going this direction. That's really the main point of this section of the paper. Okay. Yeah. So very brief conclusion. I basically want to kind of give you, so there's only 2 slides here, sort of a practical upshot and a bit more philosophical upshot. So on the practical side, bias in peer review, I argue peer review is important, and we should be worried about biases in peer review. So first of all, of course, we should continue, as many people have done, to be worried about gender bias, prestige bias, all the sort of classic biases that I guess I want to call psychological biases, just to have a term for them, to contrast them with the statistical biases that I'm interested in. But now we've seen, or I've argued, that there may be biases in peer review even in the absence of these psychological biases. Right? So if none of the individuals in the process are biased, you can still have these features that I've called connection bias, selection bias, and commensuration bias. So the thought is that we need to think really separately about ways to address these. Or really the two steps here is think about how we can measure these, and then think about how we can address these, right? Because it's not at all obvious that sort of the ways we're already familiar with of trying to address biases are going to work here. You know, if you give a training session for your editor to be less biased, that's not going to solve this problem, right? Because it's not a psychological problem. So it's potentially there's a need for different ways of addressing these, and that's something we should think about. So that's the practical upshot. More philosophical, right? I want to come back one more time to this idea of what it means for peer review to be unbiased that I started with. So this is, again, roughly the criteria that I started with, right? It's unbiased if we rank submissions on quality and we select those that rank highest. But we've seen that if you call this unbiased peer review, if that's sufficient for being unbiased, then you can still have these phenomena that I think intuitively we might call biases. And commensuration bias suggests that it might be hard or impossible to achieve this ideal, right? Because you might introduce further biases when you aggregate. And the conclusion I want to draw from this is we might also, from a more philosophical perspective, want to rethink what it really means for peer review to be unbiased, you know, and especially you might want to think about this notion of quality and the role it plays in the way we think about peer review. And the way we might want to change this to capture these kinds of biases and help avoid them. Thank you.